Good afternoon, one and all. Today also practice session. Can you hear me? Anyone respond in chat box? Yeah. Anyone respond in chat box? Can you hear me? Yeah. Very good afternoon. Yeah. Okay. Yesterday I given some problems based on binomial distribution. Yes, all of you done? Okay. Today we are going to discuss some problems on Poisson distribution. Today is also practice session for COSM. Yeah, Poisson distribution is also a discrete probability distribution. The distribution is applicable for rare events. Rare events. Yeah, I think all of you are aware of that one, Poisson distribution and rare events. Anybody tell what is a rare event? At least give one example. Yeah, please respond in chat box. What is a rare event? Or at least one example. Yeah, anyone respond in chat box? One example for rare event. Today we are going to discuss some problems on Poisson distribution. Poisson distribution is also a discrete probability distribution. Poisson distribution is also a discrete probability distribution. And this Poisson distribution is applicable for rare events. Okay, rare events means number of accidents on national highway. Number of accidents, that is a rare event. And number of printing mistakes on each page, there is also a rare events. When you're going to bank, in banks, bad checks, that means check bounce per day, that is also a rare event. Rarely they will get check bounce checks. This type of events are called rare events. In such cases, you can apply Poisson distribution. Poisson distribution. Okay. What is the Poisson distribution definition? P of x equals to x. Yeah, anyone? Only these topics are covered. That's why just I'm asking questions. E power minus lambda into lambda power x by x factorial. All of you know that formula. The Poisson distribution is defined as P of x equals to x. That is equals to e power minus lambda by lambda power x. E power minus lambda into lambda power x by x factorial. Okay. And in Poisson distribution, the mean is NP. And anybody tell what is the variance of Poisson distribution? Variance of Poisson distribution. In Poisson distribution, mean and variance are same. Mean and variance are same, NP only. Okay. And remember, number of trials, N is very large. In such case also, you can apply Poisson distribution. Poisson distribution is applicable for two things. N is very large and for rare events. In that case, probability value is very small. Small p is very small. N is very large, p value is very small. In such case, you can apply Poisson distribution. I think all of you clear the 2 points. Why I'm discussing that one? In exam, they won't mention anything. Either that is binomial distribution or Poisson distribution. That is binomial or Poisson. They won't mention anything in exam. We have to understand the point. When we'll apply Poisson, when we are going to binomial distribution. Okay. First, all of you read the question carefully and understand that point. Then you can decide which distribution we have to apply. Okay. I think for Poisson distribution, all of you understood the conditions. Now, today assignment questions, all of you read the first one. Yeah, first all of you go to first question. I shared that one that is visible. Anyone respond in chat box? I shared that questions. Image I shared. Yeah, anyone respond in chat box? The questions are visible or not? Yeah, okay. Now, all of you go through the first question. All of you go through the first question. The probability that an individual suffers a bad reaction from a certain injection is 0.001. Determine the probability that out of 2000 individuals, exactly 3, more than 2 individuals, none, more than 1 individual suffers a bad reaction. Once again, all of you read that question. The probability that an individual suffers a bad reaction from certain injection is 0.001. Determine the probability that out of 2000 individuals, exactly 3, and the second bit is more than 2 individuals, third one is none, and fourth one is more than 1 individual suffers a bad reaction. Now in the question, all of you see, they didn't mention anything, just they're asking what is the probability. Now how to decide? That is probable Poisson distribution or binomial distribution. Yeah, anyone respond in chat box? Yeah, since P is very small, very good. 57D. Yeah, I can apply Poisson distribution in 2 cases. N is large and the probability value is small. The probability value is small means that is rare event. The event is rare event, then only you can get the probability value is very small. Simply remember 2 points. N value is large and the probability value is small. In such case, you can apply Poisson distribution. Poisson distribution. Now here N value they given 2000. Yes, all of you take notes and try to solve this one. This is a practice session. I'll give questions and I will explain that one. You have to do that one. I think now all of you understood that question. Here we have to apply Poisson only. Why? The reason is the probability value, small p value is very small. Very small. That's why we have to apply Poisson distribution. Poisson distribution. Yeah, all of you try to solve that one. First item solution, given that n value is 2000, small n, and small p is equals to 0.001. Then no need to find q. Just write down small p. probability of rare event, that is denoted by small p, 0.001. We know n and p. Then all of you find out mean of Poisson distribution. The mean of Poisson distribution is denoted by lambda. Lambda is, as in Poisson distribution, what is the mean? Main formula. Yeah, anyone respond in chat box? NP, very good. Okay, we know N and P. All of you find mean lambda. Lambda is equals to NP. That is N 2000. N equals to 2000 into probability small p value is 0.001. When you are multiplying that one, you can get the mean value is 2. Yeah, all of you got it? Yeah, exactly. The mean value is 2. Very good. Now, after getting mean, all of you find the probabilities. What they asking? The first bit is exactly 3. Exactly 3. Exactly 3 means we have to find probability of x equals to 3. X equals to 3. We know the formula. Poisson distribution. In Poisson distribution, the probability distribution is P of x equals to x is e power minus lambda into lambda power x by x factorial. E power minus lambda into lambda power x whole divided by x factorial. Okay. All of you use calculators, then find out that one. Excuse me. We know lambda value. Lambda value is 2. E power minus 2 into lambda. Lambda power x, that is 3. Lambda is 2. 2 power 3. Yeah, 57D. One sec, that one. E power minus lambda into lambda power x. Lambda is 2. 2 power x. X is 3. 2 cube 8, no? 3 factorial. Right. You're right. Okay, 570. Right. The first bit is e power minus lambda into lambda power x by x factorial. Yeah, all of you find that one. That is e power minus 2 into 2 power 3 whole divided by 3 factorial. The value is 4 by 3 into e power minus 2. Very good, 570. Similarly, all of you find the second one. More than 2 individuals. More than 2 individuals. Yeah, this problem we can do in 2 ways, but we have to select the best one. Probability of x greater than or equals to 2. Probability of x greater than or equals to 2. That means what is the maximum value? 2000. That is very difficult to find. Okay, we have to choose the second way. Second, very good, 572. 572 to 1 minus p of x equals to 1. Very good. That is the best way to find this probability. Okay, the second bit is probability of x greater than or equals to 2. The probability can be found by using this formula. We know total probability. Okay, by using that one, we can find that can be written as 1 minus probability of 1 minus probability of x equals to x less than 2. Yeah, 572. One sec. That is right. X may be 0 also, no? Probability of, actually the second bit notation is probability of x greater than or equals to 2. Yeah, exactly, 570. You are right. Wait. Not equal to, strictly less than 570. 570. One sec. The notation. Yes, so actually the question is, second bit question is the notation more than two individuals. So okay, right. Yeah, okay, sorry. More than two. You are right. More than two means probability of x greater than two. Right. Yeah, you are right. Probability of x greater than two. Two individuals. The notation is probable. The second bit notation is probability of x greater than two. Okay, that is very difficult to find the basic definition. Now we can use for finding that one. 1 minus probability of x less than or equals to 2. X less than or equals to 2. That can be written as 1 minus probability of x equals to 0 minus probability of x equals to 1 minus probability of x equals to 2. Now we have to find out the three probabilities. Probability of when x equals to 0, probability of when x equals to 1, probability of when x equals to 2. Find out that probabilities, then substitute in that one. You can get the required probability. I think all of you, I hope all of you understood that one. Yeah, 572. The second bit answer is 0.3233. 572. Which one answer? Second bit? Yeah, okay. Very good. 572. Very good. Yeah, 572 got the second bit answer. That is probability of more than two individuals. Probability of x greater than 2 is 0.3233. 3233. 3233. All of you got it? The second bit answer is 0.3233. And next, all of you find out third one. Third one is none. None means, anybody guess what is the notation for that one? For third bit, I want notation. For third bit, probability of x equals to 0. Exactly, 6j. Very good. Very good. 6j. Probability of x equals to 0. None suffer x equals to 0. That is easily you can find probability of x equals to 0. We know probability in Poisson distribution, the probability distribution p of x equals to x is equals to e power minus lambda into lambda power x whole divided by x factorial. 572. What is that? You said you given some answer. 0.135. That is for third one. That is one. That answer is for third bit. Okay, very good. Your third bit answer is 0.135. All of you check. Third bit notation is probability of x equals to 0. The answer is 0.135. The answer is 0.135. Yeah, next, all of you find the fourth bit. Yeah, what is the fourth bit? More than one individual suffer. Anybody guess what is the notation for that one? I want notation for fourth bit. More than one individual suffer. Yeah, exactly. 570. The actual notation is probability of x greater than 1. By using basic formula, that is very difficult to find. For finding that one, very good. 572. 570. Very good. Actually, we require probability of x greater than 1. The probability can be found by using the formula 1 minus probability of x greater or equals to 1. That is 1 minus p of 0 minus p of 1. All of you find out p of 0 and p of 1 and substitute in that one. You can get the required probability. You can get the required probability. You all of you solve that one, fourth bit. We have to understood main in probability the concepts we have to learn. Okay. In exam they won't mention anything. 56J, very good. Your answer is right. Yeah, the result 572. Yeah, okay, very good. 56J and 572. They got answer for fourth bit. Probability of x greater than 1. The value is 0.593 or 4 or 5. The last digit may be changed depending on the values. Somebody taken something. Okay. Yeah, 0.593 is also right. 594 is also right. 595 is also right. Yeah, very good, Mo. You are doing very well. Yeah, I think the first question is completed. Still you have any doubts? I'll explain that point. Yeah, we got it all 4 bits in first question. Now, all of you once go through the second question. Yeah, once all of you go through the second question. A car airframe has 2 cars, which it heads out day by day. The number of demands for car on each day is distributed as Poisson distribution. I think the writing is not clear. I think you are following maybe. Yeah, in the question they mentioned that one. The distribution follows Poisson distribution. Yeah, 57A. What is the doubt? 57A. Any doubt? In second question, they clearly mention the Poisson distribution with mean 1.5. Okay, and calculate the proportion of days first bit is on which there no demand. No demand. Let's all of you try to solve this one. The second question. Let's all of you try to solve the second one. First, write down what is the given data. The given lambda is equals to 1.5. And the first bit is no demand. Yeah, very good. 579. No demand means probability of x equals to 0. We know lambda value and x they given. Probability of x equals to 0. But use same formula, e power minus lambda into lambda power x by x factorial. All of you use that formula, substitute lambda and x, you can get the required probability. The value is 0.223. Yeah, 579, very good. And 56J got something. Okay, you also got same thing. 56J also got it same thing. Probability of x equals to 0 is 0.22. Yeah, proportion is 22%. Very good. Yeah, very good. Yeah, 572. You also got same thing. Very good. Yeah, what is the question? The number of days they asking. Once all of you read that question carefully. Yeah, first question probability, we got it, right? Yeah, that is probability of x equals to 0 is 0.2231 or 22%. That is exactly right, 22.31. But they're asking number of days. The number of days they're asking, right? After finding first one probability, do one thing. Yeah, probability, the number of days in a year, there is no demand for that car. The number of days in a year, there is no demand of car. That is for year, in a year, the number of days is 365. 365 into the probability. 365 into P of x equals to 0. That is 0.2231. We'll get number of days for that car, no demand. The first bit is not completed. First do first one. Okay, 579. Your answer is right. I agree. But they're asking the number of days. The proportion of days, that is also right, 23.31%. But to find out number of days in a year, the number of days In a year, there is no demand for car. That is number of days in a year. That is 365 into probability of x equals to 0. We'll get the number of days. All of you calculate that one. And similarly, do the second one. Yeah, 57K. Very good. The number of days in a year, no demand for car is 80 days. 57K. Very good. 80 days. No demand for car is 80 days in a year. Very good. 57K. Similarly, all of you do the second one. Second bit. All of you do the second bit. I think all of you following this one, Poisson distribution. Yeah, okay. And today assignment also, I given 4 questions. I will share these questions to CR. All of you practice the problems. All of you practice the problems. I think all of you understood that one. When we have to apply Poisson distribution, 2 points are there. The first point is n is very large, and the second point is probability value is very small. That means the event is rare event. If the event is rare event, we'll get the probability of that event is very small. In such cases, we can apply the Poisson distribution. The Poisson distribution. And when we'll apply binomial, so what are the conditions for binomial? An experiment contains only 2 outcomes, either success or failure. And also n is finite. N is finite. In such cases, you can apply binomial distribution. Maximum students they will do mistakes in exam. They don't know which one where to apply, either Poisson or binomial. Just remember the 2 conditions. Poisson is applicable for n is large and probability value is small. In binomial, the experiment contain only 2 outcomes, either success or 2 outcomes, success and failure. And n is finite. I think all of you clear the difference between Poisson and binomial. Both are discrete probability distributions only. Binomial and Poisson distributions both are discrete probability distributions only. Okay. Now today problems also I will share to CR. All of you practice that problems. Mainly we have to understand that concept when we are going to apply binomial and Poisson. I hope all of you understood. If you have any doubts, I will clarify now. And by 2 o'clock, the quiz will start. All of you log in with KMIT online and all of you write the quiz. Today quiz is based on Poisson distribution only. Okay. Exactly 2 o'clock, the quiz will start. and by 2:20 or 2:25 they will close. 20 minutes time they will give. Okay, that's why I think all of you understood. All of you understood, right? That's clear. All of you log in KMIT online classes. By 2 o'clock, exactly 2 o'clock, we'll start the quiz. All of you write the quiz, then only you can get the attendance. Okay. Yeah, 579. Just practice. I will tell you the submission date. But you should practice. Practice is more important for probability. Okay, no need to submit today. Just practice. Mainly, we have to learn that concept and we have to practice. I hope all of you understood. Yeah, 579 clear. Yeah, all of you practice the problems. Practice is most important for probability for COSM subject. Yeah, okay. Now I'm conclude my session. Exactly by 2 o'clock, all of you log in with KMIT online and write the quiz. Okay, thank you. Thank you, everyone. Yeah, I'm closing my session. Thank you, everyone. By 2 o'clock, all of you log in with KMIT online and write the quiz. Okay. Yeah, I think all of you know the procedure. Exactly by 2 o'clock, the quiz will conduct through KMIT online. All of you log in with KMIT online and write the quiz.